Hi everyone, it's Mrs. Summer here to talk about lesson 604C, Molar Mass. In this lesson, the goals for this lesson are to review counting atoms and calculate the molar mass of compounds. So make sure you have out your periodic table and your conversion chart or the map. So if you remember that counting atoms, that the subscripts are the little lower number to the right of the element it applies to. Tells you the number of atoms and element in the molecule. Parentheses shows you the polyatomic ion group. If a number is outside of the parenthesis, like here, it means that there are multiples of that polyatomic ion. So in Ca3PO42, there are 3 calcium atoms. Phosphorus, there's 1 inside the parenthesis, but there's a 2 outside. So 1 times 2 is 2 phosphorus atoms. Oxygen, there's 4 inside the parenthesis, and then there's 2 groups of 4, which is 8 atoms. So real world comparison. Who here has been to Menchie's yogurt? There you can pick your favorite flavors of yogurt and add it to your desired toppings. Then you must weigh your frozen yogurt as it is priced per ounce. So let's say you and a friend go to Menchie's. You order 5 ounces of chocolate yogurt and put 1 ounce of raspberry toppings on top. Your friend has 6 ounces of vanilla yogurt and 2 ounces of chocolate chip. And up here, you can see the prices per each items. So for chocolate yogurt, it was 51 cents per ounce. And vanilla yogurt, it was 45 cents per ounce. Toppings is 80 cents over here. So what you did to figure out your total cost was 5 ounces of chocolate times 51 cents plus 1 ounce of toppings at 80 cents each equals $3.35. Your friend, 6 ounces times 45 cents per ounce and 2 ounces for toppings times 80 cents equals $4.30. So in the end, you both have one dessert, like 1 mole of a certain molecule, but the masses of each were different because they were made up of different items. So molar mass is the amount of 1 mole of an element or molecule weighs in grams. So it's the mass of 1 mole of that element or molecule. So 1 mole of water is 6.02 times 10 to the 23rd water molecules, which is equal to 18.02 grams of water. So we can calculate the molar mass. So the molar mass in water, H2O, count the atoms. So the steps to completing molar mass or calculating molar mass is you first count the atoms in what the molecule you're trying to find. So hydrogen, there are 2 hydrogen atoms. Oxygen, there's 1 oxygen atom. The step 2 is multiply the number of atoms by the mass on the periodic table. So we'll round to 2 decimal places here. So here, if we look, we have hydrogen's molar mass here, and oxygen's molar mass is here. So we have 2 hydrogen atoms times the molar mass, 1.01, because we rounded this molar mass to 2 decimals, equals 2.02. Oxygen, rounded to 2 decimals, was 16.00, and we had 1 of them, so 1 times 16 is 16. And then the last step is add the masses together. So we have 2.02 plus 16.000, so 2.02 plus 16.00 equals 18.02. So the units for molar mass. This is very, 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 very important. Molar mass is 18.02 for water, but what's the units? Like the definition says, it's grams per 1 mole. So when you are writing this, it is grams per 1 mole. So we write it as 18.02 grams per, and we're going to put a 1 there, per 1 mole. Whoops. Per 1 mole. To make our lives easier for our conversion factors, we write the answer like this. Okay, it's 18.02 grams per 1 mole. You'll never write it as 1 gram per 1802 moles. It's always per 1 mole when we're calculating molar mass. Write that down, ingrain it in your brain, that it's your mass in grams divided by 1 mole. We want to know what 1 mole of any substance weighs. So here's an example. What is the molar mass for K2Br? So first we count the number of atoms. In K2Br, there are 2 potassium atoms and 1 bromine atom. So then we multiply our number of atoms times the molar mass, number of atoms times the molar mass, and we get for potassium 78.2, and for bromine we get 79.90. So when we add those two numbers together, we get 158.10, and our unit is grams per 1 mole. Now you try. What is the molar mass for Ca3P2? So to calculate this, we need to count our number of atoms. There are 3 calcium and 2 phosphorus atoms. Next, we need to multiply our atomic masses by the number of atoms. So I did that, and I got 120.24 for calcium and 61.94 for phosphorus. Last, I need to add those two values together, and I get 182.18 grams per 1 mole.